Hey everyone! Today we're walking through a JavaScript text-to-speech TTS web application. Let's dive into the code and see how all its parts work together to convert text into speech. We start by loading up various essential modules. The script requires system modules like path, fs, and crypto, as well as exceed sync from child process for running shell commands. Environmental variables are loaded using .env. Further dependencies such as express for handling HTTP requests, Multer for file uploads, Sharp for image processing, and the OpenAI library are imported next. We're setting up an Express app that listens on port 5012. The view engine is set to AGS, directing it to use the views directory to store view templates. JSON requests are parsed with a limit to data size, and static files are served from a public directory. The application creates necessary directories for storing audio and uploads. If they're not already there, it uses write single quote fs.mechaQRsync, write single quote, ensuring they get created. Now, let's talk about helper functions. These functions handle tasks like retrieving API keys from the environment, loading and saving question history to write single quote question_history.json, splitting and chunking text for processing into smaller manageable pieces, and making HTTP requests with fetch JSON. Next up, we have the Inworld TTS functionality. This section covers how text is sent off to the Inworld API to generate speech in an audio format. The text is processed into chunks if needed, especially when it's lengthy, and sent in parts to generate multiple audio files that are later merged into one file with fmpeg. The code smartly handles file creation and deletion using Node.js "sfs" module, ensuring only the necessary files are kept around to save space and keep things tidy. Moving on to the Inworld API interaction, we see functions dedicated to listing available voices. These fetch voice options from the API, enabling dynamic choice of different voice patterns for the generated speech. It sorts these voices, providing a default selection if any issues are encountered. Further in, it defines video resolutions for output display purposes, mapping orientations and resolution names to actual dimensions. For rendering text onto images, which is crucial for any visual output, the script uses the Sharp library. Whether for a thumbnail or video backgrounds, the render text image function wraps and displays text in an aesthetically pleasing format. Finally, rendering highlighted frames is where the application prepares frames for video display. It highlights active sentences in different colors, creating visually engaging content that's easy to follow along with as the audio plays. There you have it. This JavaScript code showcases a comprehensive approach to converting text to speech, producing dynamic audio content with customizable visual elements, all through some clever use of Node.js and various libraries. Hope you found this walkthrough insightful.